securing websites. So the last session of today. For those of you that are new to these webinars, we conduct them usually every month. And if the title changes, there'll be lots of new content. If the title's the same, it's probably not worth seeing the same one twice. Any updates would be rather minor, but we are getting all new sessions for next month. So you don't really need to remember whether they've changed, because they'll all be new. Usual protocol: ask questions at any time, post it to the panelist. Somebody asked a question at the end of the last session whether you get the slides. You do. You get an email within 24 hours with a copy of the slides. There is I'm going to tell you about the next level after this, if you're interested in securing your website, which is a virtual workshop, which are now available for May. So I will tell you about that at the end. And we've got a podcast coming soon, which I'm not going to tell you much about now, but look out for that. That's on the way. And we've got the first one already recorded, so we've got a few bits and pieces to do after the recording, but those podcasts will be coming on a regular basis as well, so you can tune into podcasts as well as tuning into webinars. So this session is the fourth and final one for today. Bit shorter today. We've had to do them on the hour for every hour. We normally space them out a little bit more. That's my fault. Apologies for the rearranging. I'm heading off on holiday, and with the disruption at the airports, I've had to allow enough time to get through security. So apologies if that meant you had to rearrange your day, and we've done these slightly shorter, and therefore I could be accused of rushing through a few of them. But anyway, I think we've covered the main points, and you can always come to a workshop where we can do things in much more depth if you're interested in more. So those of you that are new to us, we've been around for 20 years, which makes us the longest standing full service cybersecurity expertise company in the UK. Those are some of our credentials. Those are some of the people that we provide security for and what we do for people. So our assurance division, cybersecurity reviews, is where we look at what technologies have you got and how effectively are you managing those. And we grade them, and we report technically how to improve things, but we also report to management in pretty pictures how good is your security and what you need to address and how you can measure improvements in it. So for example, we're looking in this session at securing websites. The primary technology for that is a web application firewall. So if you did a cybersecurity review with us, and it was about how secure is my hosting and my website, or that might be part of it, we have various checklists, and the top of the list for securing a website is the web application firewall, because it's fundamental to filtering out attacks and helps compensate for weaknesses in coding, patching, underlying platforms. So there's a lot of weaknesses in websites, and the web application firewall is the most effective way of blocking attacks coming through. So the first thing we look at is, do you have one in place? Then we look at, does it cover everything? Is it for all websites? Is it for all routes into the website? Then we look at the technology choice and other weaknesses in the technology, and then we look how it's configured. And because we'll sit with the people, and we can do it virtually, sit with the people who are managing it, we can assess their expertise and competence in managing that as well. And then we'll start looking at how's it been tested and confirmed it's working. So there's a whole range of things we look at to assess how effective is that web application firewall. Which is a bit different to a penetration tester, because you might, for a penetration test, say to a penetration tester, can you break in through my security to get to my website and ultimately to my data? They're looking at, is there a route today that I can spot of how to get through that? A cybersecurity review is a little bit different. That's saying, am I managing this well enough? Is it likely to protect me, not just today, but for the future? Because things might change around the security of this website. So it's a slightly different way of doing things other than a test, is to say, assess my use of the right technologies. So that's relevant to what we're doing today. We also help people with achieving standards 27001 PCI and Cyber Essentials are the biggest three, but there's lots of others. Protection of websites. Really, there are certain elements in 27001 Cyber Essentials. PCI is quite big on this because obviously PCI is meant to apply to e-commerce sites when you're shopping online and you're handing over your card data and you've got to secure that. So the PCI standard is a lot more focused and has a lot more elements related to website security than the others. So if you wanted a renowned and recognized and well-regarded international standard to justify what you do with your online security, then the PCI is the standard to look at for that. So that's our assurance division. The other half of the organization is looking at managed detection and response. So we are managing web application firewalls for people, as well as doing that wider assessment of security. We can do web application firewalls as a managed service. We're then looking at detection on a 24/7 basis. That was the focus of the last session, and then incident response, which was the focus of the first session today. And that's one of our security operations centers that you can see there. So let's delve into website security. I've just noticed that the clock on my computer has stopped, which is interesting. I've never seen that happen before. So I'm just going to remove my watch and put it here. So I'm thinking I've been going on a lot longer than 3 minutes, 38 seconds, especially with a 3-minute countdown. But that's really quite unusual, is that? I've never seen that happen. I'm assuming everything's still working, because if not, Monica would come in. She's monitoring from another room, and she would come in and start waving her arms if things weren't working. So I'm going to assume if it's all stopped working and I'm talking to myself, it doesn't really matter. Anyway, website security mistakes. So the biggest general mistake people make around website security is the website designers will understand security. So what generally has happened is people set themselves up designing websites, and then found that the people who are designing websites didn't really know how to host them and just how to make them work. So somebody would say, write me a website, and you say, well, here it is. And they go, well, what happens now? And they go, well, here you are, here's the disk. In those days, it would be a disk. Here's a disk with your website on. And they go, oh, well, thank you. What do I do now? How do I get this disk on the internet? What do I do? Do I plug it in somewhere? What happens? So they found that a lot of people thought they wanted a website, but also wanted hosting. So they had to gear themselves up to provide hosting. And they found, well, actually, this hosting lark is actually pretty good fun, because I charged somebody £10,000 to make them a website, but then I found out over the years that they're happy to pay another £5,000 a year to have it hosted. And once I'm hosting it, they always come back to me for changes to the website. And I keep getting that £5,000 a year for hosting it. I don't seem to have to do very much. So website designers got into website hosting. Now, don't get me wrong, some of them will do it very competently and will have learned the right skills, sometimes through painful lessons of all their clients getting hacked. But people believe that the website designer will understand security, and that's not necessarily the case. And I would go as far as to say it's not usually the case. But then those website designers pass that hosting to a hosting company. So you buy a website, and I say you, one of the fundamental problems is that the website security is often not seen as the responsibility of the security function in the organization, whether that's specialist cybersecurity people or within the IT team, because they don't buy the website. Somebody in digital or marketing sets up and manages the website. So often there's a breach, and we'll come in and we'll talk to somebody who is head of cybersecurity or some equivalent, and they'll be quite adamant that this breach that's happened on their website was nothing to do with them. So they've got the job title of in charge of cybersecurity, and maybe senior management might have thought, well, obviously they're in charge of it, but they don't regard it as their responsibility because it's not something under their direct control and it's not carried out by their IT team. So you really need to understand, does your cybersecurity function, however that may shape up in your organization, do they regard your website as part of the thing they're looking after? So you buy a website, you assume the people selling you the website must be good at hosting because they offer it. They then pass that on to a hosting company. And why wouldn't a hosting company provide security? How can you design websites and offer hosting and not address security? And if you're a hosting company, how can you offer to host my website that I've just designed and not provide security? And then the hosting company believe that adding all these security layers would make their solution too expensive. And that's basically what happens, because when you've shopped around for your website designers, you've considered cost. Now, I can't argue that considering cost isn't a valid business process, but because so many people over so many years have put a very high priority on cost, the providers put a high priority on providing things cost effectively. So if cost is the number one thing that people are buying, so why do you buy a website? You buy a website because it looks good, you think it's going to serve the purpose, and it hasn't cost too much. So your two criteria are great looking website, doesn't cost too much. Where's cybersecurity in that? What you should be doing is saying, well, that website doesn't look too bad, and it probably looks good enough for the function, and it seems to be quite expensive, which probably means they've put their attention into cybersecurity. It doesn't mean they have, but the logic would be they might not be the best looking website, but they're good at security, and it's not the cheapest, but good at security. Do you ask the right questions to find that out? So you've got layers that work against providing good security on websites. So remember, designers are good at design, might not be good at writing good code. So the way you write the website, the code in the website can inherently open the door to hackers. Hosting companies could be good at hosting. They might be good at building racks, putting them in fancy buildings, putting fancy physical security, putting fire suppression, maybe resilience and batteries and backup generators. All of those are all fantastic. They do nothing to prevent it getting hacked. So they may be good at hosting, not good at security. And security companies are good at security, but might not be experts at protecting websites. Protecting websites is pretty niche. So don't assume that your Cyber Essentials assessor is good at protecting websites, because it's not part of Cyber Essentials. Don't assume that your ISO 27001 consultant is good at protecting websites, because they might not be. Don't assume your penetration tester knows how to protect websites, unless they're a web app tester who understands how web applications are insecure and therefore might have gone and learned about how to protect them as well. So it's very specialist. Let's think about your system then. So a typical system, so I'm picking e-commerce because you're probably more concerned about your website if you're doing some sort of transactions. If it's just brochureware and getting hacked would be embarrassing, but not too disruptive, you might not be as concerned. But if it's a function that's fundamental to the way your business works, then like an e-commerce system would be, then you are concerned about the security. Now, I did a previous session, which I might come back to. I might do something next month on hacking techniques, but I did a session 6 months ago, say, on how to hack websites and database servers, some simple lessons in internet hacking. And this was one of the slides saying, well, here your customer's getting in, and this is what the evil hacker's trying to do. But the important thing here is to think about, I've got really 3 layers within my website or an e-commerce system. You've got some protection layer, which here I'm calling just the firewall. You've then got a web server, and then you've got a database where all the data resides. Now, at this stage, don't worry about, are they separate boxes? Because they could be virtualized. They could be working out there in the cloud in a way that you can't really ascertain what might be what box where. So there's different ways of architecting this, but you've got some functions which are protect you from getting attacked, then run the website itself, and then the data that the website is interacting with. So one of the fundamentals to think about when we start designing the website security is to understand, how is this website built? Because there are tools and frameworks to create websites. So if you go back long enough, 25, I'm feeling really old now, 25 or more years ago, I taught people how to write websites, and we wrote code in HTML, and you wrote a website partly because it was a fun way to learn, but you wrote a website by hand, writing all the code. Nobody's that daft anymore unless they've got an inordinate amount of time and it's a very specialist thing they're doing and it's quite small. So you normally would take a framework to create the website in. And here's an example. So Magento is a framework for producing websites. So what I'm looking at here is actually a website called CVE Details. I'm not sure if you can see my my mouse, but anyway, CVE Details is, according to itself, the ultimate security vulnerability data source. I'm not going to argue with that. So what you've got here is Magento as a technology used to create websites. And down here, if you look at the years, you've got for each year, you've got the number of vulnerabilities that are discovered and published about this technology. So you can see that it gets regular vulnerabilities, and in total it's had 212 vulnerabilities. Doesn't sound very good. And it isn't that it had a lot of vulnerabilities when it was first released and they've got less and less. It's had quite a lot in recent years. And then when you look at the types of vulnerabilities, there's lots around code execution. There's lots around SQL injection, cross-site scripting. These are things that are quite common attack techniques that the hackers are scanning for and trying, and things that tend to lead to the website as a whole getting hacked or all the data being extracted from it. So they're bad things, and it's got lots of these bad things happening. So what this tells you is that this needs to be carefully managed. It doesn't say don't use it. So if you've got a web design team, they do great work from a functionality and look and feel of your websites, and they've been using this for years. It isn't a case of scrap it, get rid of them, and employ new people with a different skill set and use different technologies. If you were starting from scratch and you haven't got the people and the software all in place and the history and it's already written that way, you might question using it. But if it's already in place, you might say, right, we now understand that this has got some problems. How do we make the most of it, and how do we secure it appropriately? One of the weaknesses of this, and thanks to Grumpy George for pointing this out to me. Grumpy George is one of our very technical people who you can hear on the podcast that's coming. Grumpy George said, this is all very well, Ian, but he said, my biggest problem with this site is that these individual vulnerabilities, when you look at them here, are not graded by severity. If you click on them, they are. But he said what would be typical of a technical person, he'd like it to be cleverer and more in depth. He would like these to be weighted by severity. So the CVE scoring, or the CVSS as it's actually called, scoring is on a 0 to 10 scale. So if all these vulnerabilities were 10, whoa, really bad. But if they're all zeros, who cares? So actually having them weighted and being able to say volume of vulnerabilities weighted by severity would actually be more useful. But for the level of a webinar, it's good enough to say there's a source here of saying how many vulnerabilities and how regularly do these technologies have vulnerabilities. I've picked Magento because it's got a checkered history, but you could apply the same process to any technologies. So how are websites hacked? I mentioned a few categories of vulnerability. A good way to learn how websites are hacked is to say, is there an organization who's not trying to sell me something, who researches what's known about website hacking and creates a top 10 of the ways that websites are attacked, so that I can modify my efforts to protect my website with that intelligence? And there is. It's called OWASP, the Open Web Application Security Project. They're not trying to sell you anything, and they analyze the way websites are attacked and publish a top 10. You can see here 2013, updated in 2017, and they change the order and introduce new things and remove things depending on how vulnerable are websites. And I know the security experts on the webinar are saying there's a newer version than this. There is, but the graphics aren't as good. Then they grade the vulnerabilities by how easy is it to exploit that vulnerability, how prevalent is that vulnerability and how easy is it for the hacker to detect it. So you could have a terrible vulnerability, but if there's no way of detecting its presence, and the hackers won't find it and you won't get it attacked. So it could be really bad but obscure and not easily detectable, in which case it's not too bad. And then they look at what would be the impact if that was exploited. So they've got a logical and coherent way of scoring. That gives you a final score, which then allows them to do the top 10, which is really good. Now, I know I said I wasn't using the latest one because the graphics weren't as good, but I have got an example here. But you can Google for OWASP and you can find it yourself. So this is the latest iteration. So they updated it after 3 years, and now they updated it after 4 years, which gives you an indication that things don't change necessarily every day of the week when it comes to the categories. So although we get new vulnerabilities, in the last slide, in the last session, I showed you that there was a graph showing how in 1999, 2 or 3 new vulnerabilities were discovered and published a day. And if you go through to 2021, it was 55 new vulnerabilities discovered and published a day. But this from OWASP isn't saying these are rapidly changing individual vulnerabilities like all of those on Magento. This is saying the categories of weakness that people are exploiting in hacking websites. The categories themselves tend to change on a few yearly basis, whereas individual vulnerabilities are coming out many times a day. So what do I need to focus on when I'm securing a website, writing a good quality code or protecting that website? Then this project gives us the categories. I do have a significant complaint about the level of graphics. I think they've actually moved from whoever designs their website, they've probably moved from somebody who's really good at design to maybe somebody who's good at security, or they've put all their design budget into a new logo. As you can see in the bottom corner, they've got a nice new logo, which fits wonderfully with our color scheme. But their general website doesn't look as good as it used to do. But it's the content that's important. Now, the other thing that they do, they don't just publish this top 10. This is the thing they're famous for. But they also produce guidance in each of these categories and examples for people writing websites to say, these are the errors you are making in your coding that causes this vulnerability and causes the hacker to be able to do this, and this is how to do it better. So it's a really good training resource. And if you had to comply with the payment card industry data security standard, that takes elements from the OWASP top 10, builds it into that standard, and includes a requirement for awareness of secure coding and using secure coding standards. And just about everybody interprets that as go out and use and embrace and code in line with OWASP. So it's very well regarded, which is why I'm pointing you in the right direction. So we understand then how websites are attacked, and we're trying to get the people writing websites writing better quality code. We're also trying to use frameworks that are better at security and understanding the vulnerability history of those frameworks and making sure we patch. So the big lesson from Magento is you're going to get hundreds of vulnerabilities in the next 5 years, and therefore you need to be patching for those vulnerabilities and thinking, how do I protect against them? Because when the vulnerability comes out, I might only have hours before the hackers start targeting it. So you've got to write secure code, you've got to understand the vulnerabilities of the platform and patch it, and then can we protect it in front? Can we enhance the firewall there to stop the attackers getting into those vulnerabilities? And of course we can, and that's the web application firewall. And this is where you put it. Now, some people may, well, hang on, it's not quite as simple as that, but it is. There are some examples where people do it differently. So a few years ago, some web application firewall hardware vendors were finding it difficult getting people installing their firewalls because the web application firewall needs some reconfiguration to make it work. It can be a little bit tricky, only a little bit. So they started configuring them so the IP traffic worked transparently, which is a fancy way of saying you don't have to change anything. And you had to put it outside your firewall because that was the easiest way of doing it. So you swap that over, you put the web application firewall first and then the firewall, and it made it easy. They then lied and said the reason that you did it this way was to protect your firewall, which was always nonsense. It wasn't about protecting your firewall. Your firewall is a firewall. It's meant to be protecting you. You don't have to go out and protect it. It's like hiring a bodyguard and then having another bodyguard to protect your bodyguard. You don't need two bodyguards. Well, actually, you might. But anyway, that's I'll forget that line of thought. That it was going nowhere. Anyway, your web application firewall does different things to the firewall, and logically, you let the firewall filter out a lot of the noise and the easy stuff, and then you have just the more complicated things going through to the web application firewall. You can put them on the same box, but you tend to have different modules doing different things. So they can be a combined device. A web application firewall can easily also act as a firewall. But anyway, they're doing different things. A firewall is doing a very simple level, but essential level of filtering. The web application firewall is doing more complicated things. And what it's basically doing is looking inside the packet. So the firewall simply goes, is this a web request? And it does that by looking in the packet and looking for a number. And the number is either a number 80 or a number 443. If it's a number 80, it's HTTP, which is a website. And if it's HTTPS 443, it's a website with some security. The security doesn't stop it getting hacked. That's another mistake people make in thinking, my website has got security added, I can see the padlock, and that protects me from hackers. It doesn't protect you at all. It allows somebody connecting to the website to do it in a way that isn't intercepted, but it allows the hacker to hack without being intercepted in exactly the same way as your customers can connect without being intercepted. So it doesn't make the site more secure. It makes the connection to and from the site more secure. So the firewall goes, is this a web request? Just look at this number. Does this packet of information tell me it's a web request? And if it goes, hey, I'm a web request, on you go, on your way to the web server. It does nothing more. The web application firewall goes, right, hang on, this is a web request. I might let this through. Then it does some clever things to decide, do I let it through? So the web application firewall is doing a lot more than the firewall. In terms of complexity, 1,000 times more complicated, because I use that because the firewall is applying one rule, one simple rule. A good web application firewall will be applying hundreds towards 1,000 different rules that can be quite complicated. So therefore I can say the web application firewall is doing 1,000 times more than the firewall. And that's trying to protect the web server. So what are your priorities? Your priorities are web application firewall is that first layer. Then you should penetration test the application to try and work out, is it being coded very well? This web application firewall can do lots of very clever things, but it's never going to be perfect. And if you've got the wrong technologies, it may be close to useless. So you still need to test your application. You still need to harden the system that it's sitting on. And you still need to make sure your coders are using OWASP and doing secure coding, and potentially audit them as well. The next slide you've seen again and again and again and again. It's saying protection is the most important thing. Clearly here we're talking about web application firewalls, we're talking about protection. But there is something else, and that's on the detection side. We talked about in the second session, file integrity monitoring. This can be really useful for websites. And what this is a way of checking the code or the system executable. So it's checking certain components on the website that shouldn't change. So if you think about when your website changes, you've deployed a new website, something's changed. You've patched the system, something's changed. I'm not talking about the data changing. So the database will change all day, every day, but the website itself shouldn't change. And if you know when it's changed, so you should know, have you deployed new code? And you should know, have I patched the web server? And if you know those two things, then file integrity monitoring is a very cheap and efficient way of every day getting an alert to say, has something changed? Because if you know when things have changed, and you get an alert to say it's changed, and you know you haven't done it, there's only one other explanation, assuming it's configured correctly, is that the hackers have changed something. So that detection bit for websites can be really efficient and really cost effective. And you don't, in that case, you can do something useful to get at least a 24-hour warning of a breach without looking at the sorts of complexity that we started to touch on in the last session. Now, you might go 24 hours isn't good enough. You can do a shorter time frame, but for most people, they wouldn't want to look at a report on file integrity monitoring multiple times a day. So for most people, they do it overnight and look at it in the morning and then see how something changed overnight. Payment card industry, how does this apply? So there's a couple of things here. And one of them might lead you to deduce that you don't need a web application firewall. So the payment card industry is obviously about payment cards, and the data security standard is all the best practice and requirements that have been built up over more than a decade around how to secure websites, and depending, not secure just websites, but anything that's handling card data. So it covers the machines that you use when you walk in a shop with your card to swipe your card, and it includes, you know, even if you fill in a paper form and write your card data on that form and send it off to somebody to order something, the payment card industry applies to that paper process and how ultimately that ends up with the banks. So anyway, anything to do with card data, but a big priority is websites. So the first thing is you should consider whether you need to see the card payments, because for most people running card payments in an e-commerce environment, they can architect their system so the card data goes elsewhere. There are companies who specialize in processing the card data and are certified by people like us to do it, who will do it way better than you can do it. So there's lots of options to pass card data to a third party. It will be more secure because they're experts in doing it. And your obligations for the security you have to apply to your site when you've passed the card data to somebody else greatly reduce. So it's a very cost-effective way of doing it. So you reduce your obligations. You need to consult a qualified security assessor. Don't consult me. I used to be a qualified security assessor, but I haven't been for a couple of years. And there's a new standard coming along. So I'm getting more and more incompetent when it comes to PCI. So just make sure I say consult a qualified security assessor, because I once did when I was a qualified security assessor, I did in my humble opinion, an excellent piece of work for, I think it was a council actually, maybe wrong. I think it was a council. Let's say it's a council. Anyway, I did, in my humble opinion, an extremely competent piece of work for them to advise them on what they should be doing different with their card data. So a qualified security assessor can come in and go, right, you're handling card data in these 3 different ways. This is how you're doing it. This is what's wrong and will never allow you to get secure and meet your obligations to maintain that compliance. So you should change these ways, which you can do quite quickly. If you're using millions of cards, then the assessor has to go further and start assessing it and certifying it, which is a much bigger piece of work. But for smaller merchants, it's a case of guiding you in the right direction, because ultimately you self-assess yourself. I don't think you can self-assess somebody else. Anyway, so I've done this really fine piece of work advising them, and I came in for the follow-up, and the IT manager said, well, we've got a difference of opinion on what you said. And I went, okay, that's fine. There can be differences of opinion. All of us security assessors, qualified security assessors, we've been trained by the Security Standards Council, in theory to all the same level. We're all looking at the same standard, but there may be some differences of opinion. And I said, but just remember that I'm your security assessor, and ultimately you will want me to sign off on what you do. So I've got a level of liability, and if I do an incompetent job, I could get struck off, and my company could get listed in remediation measures and all sorts of nasty things. So there's more in it for me to get it right than somebody else who isn't your actual security assessor. And then the security manager said, the IT manager said, well, the guy that I know in the pub is not an actual security assessor, but he does know one. And at that point, the FD said, I think we should move on. So you need a qualified security assessor, not somebody who knows one in a pub, and not somebody who used to be one. So you need to consult with them. And we have those people who are much better at it than me, given that I don't do it anymore. But the important thing there to look at is that you may have, and this may relate to you even if you don't do card data, that you have the concept in PCI of a referring site and the site it refers to. So you could model this on, is my site really critical or not? So PCI says the referring site, it transfers you over to another site before you enter the card data. So the card data never touches the site. The site doesn't accept the card data and then pass it to somebody else. That's processing card data. It has to comply with the full standard. But what the site does is either redirects you so the URL at the top of your web browser changes and you're on somebody like SagePay. There are other payment providers available. Or there's an iframe, which is a way of transparently disguising the fact that the card data is going off to somebody else. So the person typing in their card details thinks they're typing it into your site, but the actual bit of the screen that they're typing into is actually directly connected to somebody else and you never see that data. So by doing that, the card data never touches your website, but you still need some security. So the standard basically says that you have to patch that system, you have to scan it for vulnerabilities, you have to harden it to a certain extent, you have to use strong passwords. So you have to apply some reasonable security, but you don't need to go as far as having a web application firewall and a file integrity monitoring. Now, there is a new standard coming out in 2024. And although we have people who have access to that, it's not publicly available. But I'm personally, as a non-qualified security assessor who's not getting those updates, I'm suggesting it's likely that that requirement for web application firewalling is going to extend to those referring sites. So that's thousands of people's websites that currently don't need a web application firewall will need one. But that's me in a personal capacity saying that, not a qualified security assessor who might have access to some early drafts of the new standard. But then the critical site that does handle the card data, and if your site is critical in any regard, you might go, oh, I'm going to adopt this. The PCI standard basically outlines you need a web application firewall, you need annual penetration testing, and after major changes, you need to code review against OWASP, and you need detection and file integrity monitoring all on that site. So it's really working out how critical is the website, what's the appropriate level of security, and does a web application firewall should it play a part within that security? Now, those of you that were on the last session, we showed you the golden circle, and that was a golden circle related to detection and SIEM. The difference for web application firewalls is the technology choice is really critical. So I said for SIEM, look, a lot of the vendors are all trying to do similar things. They might have different ways of describing it, but they're using very similar open source components. They're building similar sorts of artificial intelligence. They've got fancy interfaces. It's all about getting one that's reasonable and how well you configure it and tune it and manage it. Web application firewalls, there's some fundamentally rubbish technology that can be easily hacked. So technology choice is really key. You still need really good knowledge of the system you're protecting, and the configuration and tuning is really important. But there are some technology choices that are fundamentally bad. So technology weaknesses. This is a public facing event. I can't name names. When we do workshops with limited numbers of people, I can name different providers and show you the evidence of why these weaknesses are present in different providers. Anyway, technology weaknesses, weak rule sets. A starting point for us, and I'm not saying we're different to other quality providers, is a web application firewall starting point would be, say, 900 rules. You can buy a cloud-based web application firewall where the starting point is 17 rules. And the 17 compared with the 900 is a direct one-to-one relationship in terms of quality of what it's doing. This is looking for and blocking 17 different things. This is looking for and blocking those 17 and another 883 things. Disabling rules by groups. So you apply rules, let's say 900 rules. If you apply 17, you're probably not going to block anything. But let's say you've applied 900 and something doesn't work. You then need to disable that rule. Some of the technologies either don't let you disable rules or encourage you because of the interface to disable a group of rules. So finding the exact rule that has blocked something can take a bit of effort. So people will then disable a group of rules. Suddenly the website works. That's really good, but you've now disabled, say, 10% of your rules. So then now you've, rather than having 900 rules, you've got 810 rules. You're getting closer and closer to the 17. Every time something breaks, you disable more and more rules. The rules go down and down and down until there's very little. You might as well switch it off. So they disable rules by groups. That's bad. Then the next thing people do, and some technologies you've got no choice, is you can have a rule on or off. What you should be doing is saying that rule, which is a good thing because it blocks certain attacks, causes me a problem on this one page. So why don't I remove that rule from that single page, but leave it everywhere else? So the rest of the site is still protected by that rule, but the one page where it causes a problem, it doesn't apply anymore. That is quite a in-depth way of looking at the security, but it's a way of maintaining the highest possible level. So that's about how you manage rules and how you disable them and allow traffic. 8 kilobyte inspection limit is now on 2 global providers. What that means is that when an attacker sends an attack into your site, the web application firewall only looks at the first 8 kilobytes. It's terrible, and they document, well, one of them, it's in their own documentation that this limitation applies. The other one, it's now publicly known, but they haven't exposed it in their own documentation. I was going to say, I don't know which is worse. Is it worse to have that terrible problem and not disclose it, or is it worse to have that terrible problem and think it's a good idea to tell everyone about it? It's probably worse not to tell people, because if you tell people, you can potentially, well, you could potentially ditch the technology, or you could potentially do something else to compensate. But anyway, the attacker very simply puts 8 kilobytes of random data and then puts the attack, goes to the web application firewall. It looks at the first 8 kilobytes and goes, can't see anything wrong with that, lets the whole thing through, and the attack was later. It's really bad. No outbound inspection. You might think, hang on, my web application firewall has stopped the hackers getting in. Who cares about what's going out? Well, you do, because what comes out of your system will be within certain parameters. Let's take something really simple. Let's say that you've got a website with a big database, and people are querying that website with little queries and getting little answers. This is a simplification to quite an extreme level. So let's say your website works with little requests come in and little bits of data go out. Suddenly, a gig of data tries to get out. So I'm using an extreme example. That doesn't look normal. Your website normally has little bits come in, little bits go out. If suddenly a load of data tries to go out, you've just been hacked, and the hacker has done something, and there are techniques, as in I showed in my little hacking course a few months ago, that you can extract the whole database. If the website has a particular weakness, you can give it an instruction, tiny little instruction, that tells it to send you the whole database. So your web application firewall should be looking at what's going out and go, whoa, hang on, what's going out is not normal. It doesn't fit my profile of what's normal, so I will stop it happening. Makes sense. You need to outbound inspection. A lot of them don't. Error replacement. This is a bit more subtle. This is saying so you're a hacker trying to hack a website. They've got a really good web application firewall. It's got hundreds of rules. It's got some other sophisticated cleverness in there. You try and hack it, and you get blocked. And you can see that you're getting blocked by a web application firewall. Maybe you're not sure, but you get an error message. So you try something, error message, try something, error message. Or you try something and just nothing happens either way. So maybe you get an error message, it may be that you don't see anything as a result. So you're trying different things and you get the same result, which is nothing. Then you get a different result. you get a different error message, because previously your attacks were being blocked by the web application firewall. Now you've got through the web application firewall, but the web server has said, no, I don't like that. And it's giving you an error message, but you spot the difference. Not difficult. You're looking for the difference. You're going, hang on, this happened to all these attacks, but then I got an error message from the web server. That tells me whatever I did got through the web application firewall. You can iterate an attack. You can go, I've got further. Then you can try different things, get different error messages. So it's an iterative way of hacking a website is what hackers do. It's what a good web application penetration tester will do. So it's really important that web application firewall takes error messages generated by the web server and replaces them with whatever generic reply it gives to attacks. So when an attacker tries things, the web application firewall is going, no, 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 no. But then when it gets an error message coming back from the web server, it replaces it, doesn't let that out, and replaces it for what it does when an attack is blocked. Now, if you then go in, well, hang on, I use that for debugging because if somebody tries something and it doesn't work, I want to know what error message they get, then yes, I completely appreciate that is good for debugging. Find a different way to debug. You can have a different route into your web server and you can get see those error messages. But if you rely on your consumers and your users to debug your system because they can see the error messages, you need to find a smarter way of doing it because it's compromising your security. So those are really important principles when it comes to the technologies, partly how you use them, but also which ones you choose. Third-party countermeasures, third-party critical measures. So you really have to understand with third parties, and we did a little bit of this in the last session, is understand for the third parties what's their specialism. And no, actually we did it at the start of this one in terms of understanding, are they web designers, are they hosters, are they providing security? Understand the specialisms and understand what security features you're getting from each provider. For website breaches, it's normally the case that everybody assumes security has been done by somebody else and everyone assumes that security was built in, and the gaps are actually huge and nobody identified the gaps. So it's the gaps that you're looking for. So you understand what each person's doing and what are the security features of that. And then I said last month I might have got rid of this because I wasn't sure quite the appropriateness of quoting Russian in the current circumstances. But there was a very clever thing that Ronald Reagan did when he was negotiating with the Russians, that he said, look, we're going to try and reduce nuclear weapons and we're going to trust each other, but we're going to verify. So he used the term trust but verify, meaning we will trust each other, we'll develop trust, but we'll also send each other delegations to check what we're doing. And the real genius of that phrase was that it's actually a direct translation of a Russian phrase, and it's an old Russian phrase, trust but verify. And I think this applying to, you've got these specialisms, these people applying different functions, you need to trust them but verify and check what they're doing. So my rewrite of that for terms of website security is we need a bit of less trust and a little bit more verification, because people are just believing blindly that security is a feature of their web hosting and their web design, and it's often not, and you don't want to discover that with a breach. So according to my computer, I've been going on for 3 minutes 38 seconds and there was a 3-minute countdown, so I'm 38 seconds into this, but according to my watch we're coming up to 1 o'clock. So just worth mentioning, today, free webinar, we can point you in the right direction, some interesting stuff, hopefully. We can't name names and we can't relate it directly to your technologies and your situation. We can in a workshop. So in May, you can book a virtual workshop, and we have one specifically on website protection. So it's not just web application firewalls, but it's a broader, how do you protect your website? We do this by limiting the numbers, as Claire said in the last session, maximum 10 organizations. We do pre-scoping, so a consultant will engage with you to understand how is your website built and hosted, and what protection have you got currently? Then we tailor the content. So if all the people in the 10 organizations have never heard what a web application firewall is, but they're all using technologies that they're stuck into that all need it, that will be the focus. If they're all using a certain technology and it's got a weakness and we need, so if they're all using one of these cloud providers with an 8 kilobyte limit and they're tied into a 3-year contract, we will help you understand how do you get around that and try and work within that severe limitation. If you've got a website and you've never got a web application firewall and you're looking to do it yourself, we'll help you in that direction. So we tailor the content to your challenges and your situation, and it's the closest you can get to us working with you on an individual basis, but you're spending only half a day and the cost is really quite reasonable. So those are in May. Not sure the exact dates for the website one, but it will, somebody's telling me, what is it? 23rd. So the first day is on website protection. So the 23rd of May in the morning. If you're close to or fancy a trip to Yorkshire, we have a space we conduct this from and you can attend in person. But if you attend virtually, we share screens, you can see us, hear us, and we can share an electronic flip chart as well. So we can do all the things we'll be doing in the room. The advantage of the room is that you get to come to sunny Yorkshire and we'll provide the refreshments. And you do get to see us face to face. So that's in May. There will also be some new webinars in May. I don't have a date, but we will tell you about them. And they will be all new next month. So thank you very much, people that have attended. Thanks if you've attended all of these. I'm assuming I don't have any questions. No. So thank you everybody who's attended today, and look forward to seeing you either on a workshop where I will be able to see you, and if not, then on the webinars next month. And look out for the podcast on why you need MFA. Pretty obvious you do, but also how do we hack you, or how the hackers hack you even when you've got MFA switched on, and what can you do to fix that, because that's the next stage of your security when it comes to cloud-based and internet-based logins. So thank you very much, and I will see you at a future event.